proteins. And it was pretty stunning when we put this in the cell, and you'll appreciate our very sophisticated graphics here. The new chromosome went into the cell. In fact, we thought this might be as far as it went, but we tried to design the process a little bit further. This is a major mechanism of evolution right here. We find all kinds of species that have taken up a second chromosome or a third one from somewhere, adding thousands of new traits in a second to that species. So people who think of evolution as just one gene changing at a time have missed much of biology. There's enzymes called restriction enzymes that actually digest DNA. The chromosome that was in the cell doesn't have one. The chromosome we put in does. It got expressed and it recognized the other chromosome as foreign material, chewed it up, and so we ended up just with the cell with the new chromosome. It turned blue because of the genes we put in it, and with a very short period of time, all the characteristics of one species were lost, and it converted totally into the new species based on the new software that we put in the cell. All the proteins changed, the membranes changed. When we read the genetic code, it's exactly what we had transferred in. So this may sound like genomic alchemy, but we can, by moving the software of DNA around, change things quite dramatically. Now, I've argued this is not Genesis. This is building on 3.5 billion years of evolution. And I've argued that we're about to perhaps create a new version of the Cambrian explosion where there's massive new speciation based on this digital design. Why do this? I think this is pretty obvious in terms of some of the needs. We're about to go from 6.5 to 9 billion people over the next 40 years. To put it in context for myself, I was born in 1946. There's now 3 people on the planet for every one of us that existed in 1946. Within 40 years, there'll be 4. We have trouble feeding, providing fresh, clean water, medicines, fuel for the 6.5 billion. It's going to be stretched to do it for 9. We use over 5 billion tons of coal, 30 billion plus barrels of oil. That's 100 million barrels a day. When we try to think of biological processes or any process to replace that, it's going to be a huge challenge. Then, of course, there's all that CO2 from this material that ends up in the atmosphere. We now, from our discovery around the world, have a database with about 20 million genes. And I like to think of these as the design components of the future. The electronics industry only had a dozen or so components, and look at the diversity